Look closely at this yellow, orange, and black world. That is not paint. That is a wound that never closes. For decades, we assumed the outer moons of Jupiter were frozen, dead and silent, balls of rock and ice locked in an eternal, gentle orbit. We were wrong about one of them. Io does not sleep. Io does not heal. Io is being tortured every second by the planet it can never escape. Welcome to the most violent surface in the entire solar system. Let's start with the color. From a distance, Io looks almost cheerful. A speckled orange marble, dotted with black spots and rusted red streaks. Some early scientists compared it to a pizza. But those splotches are not decoration. They are open sores. Each dark spot is an active volcanic crater. Each red streak is a river of molten sulfur, frozen mid-flow. Io has more than 400 active volcanoes. Earth, by comparison, has around 1,500, but almost all of them are dormant, sleeping for centuries at a time. On Io, they never stop. At any given moment, dozens of eruptions are happening simultaneously across the surface. Lava fountains rise kilometers into the black sky. This is not a planet with volcanoes. This is a planet made of volcanoes, wearing a thin crust as a disguise. But why? The answer is a trap. Io orbits Jupiter in a rigid, mathematical dance with two other moons, Europa and Ganymede. For every one time Ganymede circles Jupiter, Europa circles twice, and Io circles 4 times. This is called orbital resonance, and it sounds elegant. It is not elegant. It is a mechanism of slow, permanent violence. Because of this resonance, Io's orbit is never allowed to settle into a perfect circle. Jupiter's colossal gravity and the competing poles of Europa and Ganymede constantly stretch and squeeze the moon, again and again, orbit after orbit, for billions of years. Imagine squeezing a rubber ball in your fist, over and over, without rest. The ball would grow hot. Io's entire body flexes by up to 100 meters with every single orbit. That flexing generates friction. That friction generates heat. And that heat has nowhere to go but out. Io is not a volcanic world by accident. It is a world being physically kneaded alive by the gravity of its own master. This is called tidal heating, and on Io, it is extreme enough to melt entire regions of the interior into a hidden ocean, not of water, but of magma. Now look at Loki Patera. This is the largest volcanic feature on Io, a lava lake wider than 200 kilometers, a churning black cauldron that periodically overturns, sending a wave of fresh magma across its own surface in a slow, glowing tide. And then there is Pele. Named after the Hawaiian goddess of fire, this volcano does not simply erupt, it launches. Plumes from Pele shoot debris and sulfur dioxide gas over 300 kilometers into space, fast enough to briefly escape Io's gravity entirely before falling back down as a fine, freezing snow of sulfur. This is a moon exhaling its own surface into the void. In 1979, the Voyager 1 spacecraft became the first to witness this directly. An engineer named Linda Morabito was analysing navigation images when she noticed something impossible on the edge of Io's disk. A faint, umbrella-shaped cloud rising off the surface into black space. It was not a smudge. It was not an error. It was a volcanic plume, caught in the act. The first active volcanic eruption ever observed anywhere beyond Earth. That single image rewrote what we understood about small worlds forever. But this violence comes at a price, and it is not only Io that pays it.
Jupiter's magnetic field is the most powerful of any planet in our solar system, and Io sits directly inside the most lethal part of it. As Io erupts, it bleeds a ton of material into space every single second. Sulfur, oxygen, sodium, which Jupiter's magnetosphere catches and accelerates into a massive invisible ring of radiation called the Io plasma torus. This torus is a belt of charged particles so intense it would kill an unshielded human in minutes. When NASA sent the Galileo spacecraft to study Jupiter's moons in the 1990s, engineers had to make a brutal calculation. Every close pass by Io meant flying directly through this radiation storm. Galileo's electronics were slowly, silently damaged with each flyby, absorbing years of radiation exposure that its designers had never fully planned for. It kept flying anyway. Mission controllers pushed the spacecraft closer to Io again and again, trading its lifespan for images of a world no human will likely ever touch. Because of that sacrifice, we now know Io does not just have volcanoes, it has no craters. None.
Every other rocky body in the solar system, the Moon, Mercury, Mars, is scarred with billions of years of asteroid impacts. Io should be too. Instead, its surface is almost impossibly smooth of any impact scars, because Io resurfaces itself completely every few thousand years. Fresh lava buries the old wounds before they can even become scars. Io does not remember its own past. It is erased and rebuilt, over and over, on a geological timescale almost too fast to comprehend. Any crater from an asteroid strike 1 million years ago is already gone, sealed beneath a fresh layer of molten sulfur and rock. This is a moon with no history, only an eternal, burning present.
And it will not stop. As long as Jupiter, Europa and Ganymede continue their locked orbital dance, Io will keep flexing, keep tearing, keep bleeding lava into the dark. There is no scenario in which Io heals. There is no future where this moon goes quiet. We looked at Io expecting a dead rock. We found a living wound, kept open forever by the gravity of a planet it can never leave. Some prisons are built from walls. Io's prison is built from gravity.